All right, let's take a look at one last situation. How do you identify linear versus nonlinear functions when they're in equation form? Well, turns out we already have the tools for this. That if we go back to what we learned in chapter 4, that one of those forms that we learned about, in this case slope-intercept form, y equals mx plus b, is going to help us out here. And it turns out that if you can make an equation, if you can isolate y and make it fit this format, where you've got something x plus b, the slope, and then your y-intercept, then it is a linear function. If for all your manipulation you cannot get it to change into slope-intercept, then it's nonlinear. All right, so let's take a look at a problem that I pulled. Here's a multiple choice problem. Which equations represent nonlinear functions? Well, if I take these one by one, what I'm going to try to do is I'm going to try to see if these match up with slope-intercept. Let's take a look at this first one. I'll put it over here. Y equals 4.7. Now, at first glance, we might think, I don't think so. But we've seen this before, that one way to think about this equation is y equals, and what's missing here is x, but that just means that there's 0 x's plus 47. So in this case, this does fit slope-intercept. If I look here, y equals, and then m, the slope is 0 in this case, a flat slope, plus 4.7 for our y-intercept. So that is in slope-intercept form, so that would be considered linear. Now let's take a look at b. All right, b, we've got y equals 3x squared plus 2. So you might think, oh, we could do this like the last one then. Let's fill in that missing number with a 0. So you might do something like this. Y equals 3x squared plus 0. Okay, but this still doesn't fit. This doesn't work for us. Okay, and what's new here is this exponent. Okay, slope-intercept form should be y equals mx plus b, not y equals something x squared plus b. So the 0 is fine, the 3 is fine, but this exponent makes it nonlinear. So this one would be one of them. This would be a nonlinear function. All right, so look out for those exponents when it comes to our variable x. It should just be a plain old x, not x squared or x to the third power or what have you. All right, let's take a look at c. Y equals 4 divided by x. Now in this case, that doesn't fit slope-intercept either. Again, I could put the plus 0 to fill in the y-intercept, but here it should be y equals something times x plus 0. And the fact that x is on the bottom of the fraction, this is not multiplication, this is dividing by x. All right, so 4 divided by x, we can't rearrange it to make it fit this format. So in this case, once again, it's nonlinear because it doesn't follow the slope-intercept format. All right, and then we've got d. D doesn't fit slope-intercept right now, but if I were to do a distributive property and clean it up a little bit, I would get y equals 4x minus 4, which does fit slope-intercept. Y equals 4 is our slope, and the minus 4 is our y-intercept. All right, so in this particular case, it was 2 and 2. Two of these linear, so a and d, but the ones I wanted, which equations represent nonlinear functions? Well, it would be b. It's b, once again, because there shouldn't be any exponents. It should just be 3x, but not 3x squared. And c. C is nonlinear, all right, because x is on the bottom of this fraction. We're dividing with x when we should be multiplying with x. All right, so that's how you identify linear versus nonlinear. Linear equations, you can turn them into slope-intercept form. Nonlinear equations, you can't.